So hi guys, mayong adlaw. Welcome to NatzMath TV. So in this video, I will be presenting to you about multiplication of rational algebraic expressions. In my previous video, I had presented to you about addition and subtraction of rational algebraic expressions. So this time, this is multiplication of rational algebraic expressions. So we will start this lesson after this intro. So multiplication of rational algebraic expressions. So how do we multiply rational algebraic expressions? So to multiply a rational algebraic expression, we need to remember these three steps. Number one, we need to factor out all the polynomials that can be found in the numerator and denominator completely. Then number two, after factoring, we need to cancel out all common factors in the numerator and the denominator. And number 3, the remaining factors should be multiplied, or you can leave your answers in factored form. So, let us now proceed to our first example. Example number 1. We are given these rational algebraic expressions x squared minus x over 2x times 5x minus 2 over x minus 2. So we will start with the first fraction. We have here x squared minus x. So how do we factor out x squared minus x? Since as you can see here, we have x squared and x, so we can factor out the common factor here, which is x. So the common factor in this polynomial is x, so that's why we factor out the x here. So what remains shall be x minus 1. Because when we multiply x times x, that is equal to x squared, and x times negative 1 is negative x. Then we shall leave 2x the same because 2 times x is not factorable anymore. So we shall leave 2 times x. Then, times, proceed to the second fraction. We have here 5x minus 2. Since 5x minus 2 is not factorable, so therefore we shall leave 5x minus 2. The same also with x minus 1. X minus 1 is not factorable, so there are no common factors. So therefore, we shall leave x minus 1 as the same. The next step is to look for the common factors that can be found in the numerator and the denominator. So in this case, we have here x minus 1 in the numerator, and we also have x minus 1 in the denominator. So what we need to do is to cancel out this x minus 1 and x minus 1 because they are common, so that shall be cancelled out. And another is we have x in the numerator and x in the denominator. So we have common factor x and x, so we can cancel out x. So therefore, what remains in the numerator, since we have cancelled out the numerator here, what remains in the numerator is 5x minus 2. That's why we have here 5x minus 2 over what remains in the denominator is the 2. So that's why we have 5x minus 2 over 2. Now, we cannot cancel out the 2 here, 2 and 2, because the operation between 5x and 2 is subtraction. So we can only cancel out common factors in the numerator and denominator if the operation is multiplication. So we cannot cancel out the 2 here, so this is now our final answer. Now let's proceed to our second example. We have here the first fraction, 17 over 3x minus 5y times 3x minus 5y over 34. So let us evaluate the numerator in each of these two fractions. So we have here 17, and since 17 is already a prime number, we cannot factor out 17 anymore, so that shall remain as 17. The same also with 3x minus 5y. There are no common factors, and this binomial is not factorable anymore, 3x minus 5y, so that shall remain as 3x minus 5y. The same also with the numerator in the second fraction, that is 3x minus 5y, so that shall remain 3x minus 5y. But for 34, we can factor out 34 using 17 as one of the factors. We can use 17 times 2, because 17 times 2 is 34, and we have common factor in the numerator, 17 and 17. So therefore, after factoring 34, 17 times 2, we can now cancel out common factors. So we have here 3x minus 5y in the numerator and another 3x minus 5y in the denominator. So we can cancel this out. And another is we have 17 in the numerator and 17 in the denominator. So, what shall remain in the numerator is nothing but we have cancelled out everything in the numerator, but that doesn't necessarily mean that we have nothing left here. What is left in the numerator is 1. What remains is 2. That's why our final answer is 1/2. Now, let's proceed to example number 3. We are given x squared minus 8x plus 12 over x squared minus 16 times 4x plus 16 over x squared minus 4x plus 4. So, let us factor out each of the polynomials in the numerator and denominator. So, we will start with the first fraction, x squared minus 8x plus 12. So, how do we factor this out? When we factor this out, we can have these two binomials. We have x minus 6 times x minus 2. So these are the factors of this trinomial. Next is, since x squared minus 16, so the factors of x squared minus 16 are x minus 4 times x plus 4. Then for the second fraction, we have 4x plus 16. So common monomial factor here is 4. So we factor out 4. What remains is x plus 4. Then for the denominator, we have x squared minus 4x plus 4. Perfect square trinomial. So the factors are x minus 2 times x minus 2. So after factoring the polynomials in the numerator and denominator, we shall now cancel out the common factors. So first common factor, we have x minus 2 and x minus 2. So we cancel this out. Then another is we have x plus 4 and x plus 4. So cancel this out. So there are no more common factors in the numerator and denominator. So what remains in the numerator? We have here one factor is 4. Another is x minus 6. So we have 4 times x minus 6. And the other one in the denominator, we have x minus 4 times x minus 2. So we have x minus 4 times x minus 2. So this is now our final answer. Next example, example number 4. We are given x squared plus 3x times x over x squared plus 5x plus 6. So again, we factor out the first numerator, x squared plus 3x. So we have in the numerator x squared plus 3x. Again, the same common factor is x. So we factor out x. We have here the x times what remains is x plus 3. Because when we multiply x times x, that is x squared, then x times 3 is equal to 3x. Since this has no denominator, so this has an assumed denominator 1. So every polynomial has an assumed denominator 1. So that's why we have here 1. Then for the second fraction, we have the numerator x. And since we cannot factor out x, so that shall remain as x. Now for the denominator, x squared plus 5x plus 6, the factors of this trinomial are x plus 2 times x plus 3. Then afterwards, we cancel out common factor. We have here x plus 3 and x plus 3. Cancel out. We cannot cancel out both x here because they are both in the numerator. So what we need to do with x and x here is just simply multiply. So x times x is x squared. Then 1 times x plus 2 is x plus 2. So our final answer is x squared over x plus 2. So let's proceed to example number 5. We are given 5x plus 30 over 2xy minus 6y times 4x squared y over x plus 6. So factor out the numerator, 5x plus 30. Common monomial factor between 5x and 30 is of course 5. So we factor out 5. Then what shall remain inside the parenthesis shall be x plus 6, because when we multiply, 5 times x is 5x, then 5 times 6 is 30. That's why we have 5 times x. Then for the denominator, we have here 2 and 3. So common factor is 2, and aside from 2, we have here y and y. So common is 2y. X is not common because the second term has no x as the variable. So common factor is 2y. What remains inside the parenthesis shall be x minus 3. Why? Because when we multiply 2y times x, that is 2xy, Then when we multiply 2y times negative 3, that is negative 6y. Then for the numerator, we can factor this out by using prime factorization. We can have 2 times x squared times y, or we can have 2 times x times y. For the denominator, x plus 6, since this is not factorable anymore, so that shall remain x plus 6. Afterwards, we cancel out common factors, which is x plus 6, and another, we have 2 and 2. So we cancel out 2 and 2 here. And another is y and y. So cancel out y. So what remains in the numerator is 5 and 2x squared. So we multiply 5 times 2x squared. That is 10x squared. Then for the denominator, we have x minus 3. So we copy x minus 3. So since there are no common factors anymore, so we consider this one as our final answer. Okay, so that's it. I hope you have learned something from this video. So please do not forget to subscribe, like, and share to your friends. Thank you and God bless.